So far we have seen 1D arrays or single dimensional arrays, which look like a list of numbers or a list of characters or a list of elements of any data type. But sometimes you may need to work with higher dimensions. You may need 2D arrays, 3D arrays, or even higher number of dimensions. So the most common use case after 1D array is 2D arrays. So we will start with 2D arrays. If you understand this concept well, you can extend the same concept to higher dimensions also. So let's see what are 2 dimensions and how we can represent it in different languages. So it's a array of 1D arrays. So it's a array of arrays. So what was array? Array was a list of elements of some data type. So here that data type is 1D array. So let's say we have a 2D array of integers, then that means we have multiple 1D arrays of integers and we group them together into one array. So here the arrays themselves are serving as the data type. So it's the same concept that we are taking from the 1D array case, and it has 2 dimensions in for 2D arrays. Of course, that's obvious. And then generally we call those dimensions as rows and columns. The first dimension we call rows, second dimension we call columns. So let's say we have a 2D array which has R rows and C columns. Then we will call it R cross C array. So there are how many elements? R cross C elements. If you multiply R and C, you get total number of cells in a 2D grid. And each grid will have one element. So this will have R cross C elements in it. And all the elements should be same type. So all the other definitions of array holds here also. It's only about dimension. So let's see this. So this has 3 rows and 4 columns. So again, I am taking the 0 based indexing. There may be some languages where this is not the case, but this is the case in most of the major programming languages. So the first cell, so we start from row. So this is the first row. Then we have second row. So row 0, row 1, row 2. And these are columns. So now using the combination of row and columns, you can access any of these cells because each will have a unique combination. So if you look at this first row, all the elements, all the 4 elements have the same row number, that is 0, but they have a different column number. So none of the combinations are same. So the first one we will denote by 0 0, that is 0th row, 0th column. Next one 0th row, row number 0, first column, and you can see this is row number 0, and if you look above it, it's column 1, so 0 1, 0 2, 0 3. Similarly here 1 0, 1 1, 1 2, 1 3, and so on. So let's say we want to access some element at row number R in general. So this small r, small c are some particular values of row and columns, just like the 0 1 and 2. So if we want to access an element at row number R and column number C, just go to row R, and intersect with column C. So they will intersect at a point, and that will be this cell. So let's take an example. So let's say we want to access row 1 and second and column 2. Column 2 is third column, 0 1 2. So this element, the value, whatever is the value here, will denote A12. So here A is the name of this complete array, 2D array. Now let's see how we can initialize it. So we will see in all the 3 major languages that we are talking. So first let's see how we can initialize 2D arrays in C++. So we already know how to access it. Now we are talking about initializing or updating the value. So one way is that you provide the dimensions. So we will be talking about 3 cross 4 arrays that we saw in the example. So one is that you write the data type int A. So remember, in the single dimensional array we were writing, if we have 3 elements, then we would have written int A, then this square bracket 3, and this second dimension was missing. And in the right hand side we would provide 3 values. So here also, if you see, it's an array of arrays. So here the data type of each element is an integer array of 4 elements. So this is the first one, this is the second one. So each of these are themselves arrays. So we are initializing it like that. So an array where each of the 3 elements are an int array of 4 elements. So 0, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. This is one way. You can also skip these inner values and it will be filled in this same order. First 4 values will comprise the first row. So 0, 1, 2, 3 will go into the first row, then 4, 5, 6, 7. So this is same as that, but the first one is much more clearer. It explicitly is telling that this is the first row, this is the second row, this is the third row. Here it is inferred, like first 4 elements comes to the first row and so on. And again these values will come here, 0, 1, 2, 3. For both the initialization, this will be the view of that 2D array. 0, 1, 2, 3 come in the first row, 4, 5, 6, 7 in the second, 8, 9, 10, 11 in the third. Now we will take the exact same example and see how we can do it in Java. You can also first declare it of that size and then start filling that. You can initialize with a fixed value 0 and then start initializing with some specific values. You can also do that way, that is also accepted. These are not the only 2 ways, I have just written it. Of course you can first declare it or initialize it with 0. You have to just write one value 0 and then just access it using that example, remember. So like this value was at A1, 2. So that way you can fill all the values. Now let's see in Java. So we declare a new int array of size 3 cross 4, and this new int, it will fill all the values with 0. So the default value for int will be 0. So all the elements will have a value of 0, but we want 0, 1, 2, 3, 4 all the way up to 11. So what we will do, we will first write this first line, then specify the values for all the cells one by one. Of course you will not write like this. You will run a for loop for int I equal to 0 to whatever is the row number minus 1, and within that a nested loop for column number equal to 0 to whatever is the column number minus 1, and then if it's a continuous value, you can add a counter, count plus plus, and that array will be initialized. Or you can also, without writing the size here, you can put the values on the right side using this way. So this is similar to the first method of that C++, but both are doing the same thing. I have not initialized all the values. You can fill that up and you will get exact same array. Now in Python 3, again in the single dimensional case, you remember if we write something, so if we write some value in the bracket, let's say 2, and this is a square bracket, and then multiply it by some value, let's say 3. So this, what it does, it creates a list of 3 elements, and each of these values are 2. So if you want to repeat the same value multiple times, in Python you write like this. So if you know this much syntax, then you can think why this is initializing that array. So if you look here, it's a 0 within this square bracket multiplied by 4. So there are 4 zeros. So this list with 4 zeros, and the entire array or the list multiplied by 3. So again you are getting the same thing, array of arrays. So this inner thing is an array of 4 zeros, and take that 3 times. So this is a 3 cross 4 list, each having a value of 0, all the elements. Now again it's your task to initialize all the values one by one for all those cells. You can also write it like this, 0 for I in the range 4. So range 4, 0, 1, 2, 3. So this is 4 zeros, a list of 4 zeros, and this entire list 3 times. So again the same thing, and again you will have to initialize and you will get the same 2D array. So I will also run through an example in all the 3 languages. So we will write this same thing and you can see that it works. What we will do, we will also print the values of all the these values, so that you get the idea that we are setting the correct value. So let's see the working example of that. So let us first initialize 2D arrays in C++. So we will write int a 3 4 4 5 6 7, and finally the third array of integers 8 9 10 11. And now let's print it. So here the number of rows is 3 and number of columns is 4. So aij will print the current value, and let's separate them with a tab, and after each row print the new line. And let's see what is the value. And you see 0 1 2 3 4 5 6 7 8 9 10 11. And this is the same thing that we will get if we had not written it in this form, but instead all in single array. So let's comment it out. And you can see there is no change. Now let's write it in Java. So one of the methods is that we write it in the same fashion that we wrote in C++. And then system dot out dot print line or rather print, and then we can add one tab character, and then and now you see the same array is being printed here. And the same way you can initialize it in an alternate fashion, the first method or the second method. And we can have the same loop. And the same array is printed. Finally, we can do it in Python. So a equal to 0, take it 4 times, and then the entire thing take it 3 times, and then again initialize it one by one. And now we are printing it. So print in fact, we can print the array itself directly in Python. No need to do all of this. And let's see if it's able to print or not. It does. So you can see it's first row, second row, and third row. And in the same way, you can have the other syntax also. So let's comment this one out, and we will write a equal to 0 for I in range 4. So it creates a list of 4 zeros, and then the complete list repeated 3 times. And now let's run it, and we get the same thing. So I hope you understood the concept. You can apply the same concept to 3 dimensions, so there will not be any difference here. The same thing will be applicable there also. So I wanted to talk about 2D arrays in detail, because in lots of graph problems and where the input is given in the form of a 2D grid, and many more problems. These 2D arrays are very helpful. So you must be fluent in how to quickly write or initialize and modify or access the values of 2D array. In fact, for C++, if you don't even need to, if you don't know the size beforehand, then you can use vectors. Similarly, if you know the number of dimensions of these inner vectors but not the outer one, how many of such values are there, you can instead use vector of vectors. So one very useful application would be when you are solving problems related to graph where you have adjacency list. So adjacency list is a list of vectors. So where if we have let's say 5 nodes in the graph, then we will have neighbors corresponding to those 5 nodes. So we will denote those 5 nodes with 0, 1, 2, 3 and 4, and let's say each of them have some neighbors. Let's say 0 is connected to 2 and 3. So the adjacency list, so the neighbor list for 0 is 2, 3. Similarly, 1 is connected to let's say 2, so it has just one value, and so on. So you see, this is the outer list is fixed. It will have 5 values corresponding to the 5 nodes, but the inner ones have variable number of nodes. So for example, the 0th node has 2 neighbors, node 1 has just one neighbor, and maybe 4 does not have any neighbor. So it's an empty vector. So this is not the case like a rectangular grid. So in that case, we will use a vector of vectors. So each element can have different number of neighbors. So we will talk about that when we come to solving graph problems in detail. So I hope you liked this lesson. We will start with linked list in further lessons. So see you in the next lesson. Thank you.